What's up, you guys? Hope you're all doing good and welcome to our A Dream channel once again. For those who are visiting our channel for the first time, let me quickly introduce myself. I'm Jagdish, a software developer with around 10 years of experience. In our channel, we have been trying to cover the basics of Java programming. If you are interested in learning Java from the basics, consider subscribing to our channel and check out our videos as we have been trying to cover all the basics of Java programming. In our recent past videos, we have been discussing about a collection framework available in Java, and we have extensively spoken about one of the list implementation called as the array list in Java. Today in this video, we are going to talk about one other implementation of the list interface called as the linked list in Java. So before getting into the actual programming concepts and how to create a linked list, we need to talk about why linked list when there is already a list implementation that is available. Broadly, when you see list implementation falls into three of the categories. Like there are three main implementations of the list interface. So we have the array list, which we have seen in our recent past video, and today we're going to talk about a linked list, and we have a vector. So why there is a need to create one other implementation of a list interface when there is already array list in place, which means that linked list in certain ways it is unique and different from the array list, and it has its own unique features. The most important feature of a linked list is that here elements are not stored in a continuous linear structure, so which that the relationship between the elements that are stored in the linked list is the address or the pointer that we have in our linked list. So we have a documentation in place for you. So there we have written exclusively the terms available. So each element in a linked list is called as a node. So this node will be split into two halves, where one part of the node is going to contain the content. For example, if it is a linked list for storing the string, one part of your node is going to hold the string element, and the other part of the node is actually going to store the address or the reference to the next element that is there in your linked list. So since there is this connection between the nodes that are available in linked list, the addition and the removal of the element from the list becomes very simpler. Let's take a scenario of adding or removing an element from an array or an array list and compare it with a linked list. When you add or remove an element from an array, for example, if an array's index begins with 0 and if it has 5 elements, and if I wanted to remove the third element gets removed and all the right hand side elements should be shifted to the left. And at the same time, if I insert the elements in between the elements, then you have to move all the elements to the right and then you have to insert an element. That complexity is reduced to your greater extent in your linked list implementation, where it requires only the address change. Since each node is going to contain a content and an address, if you wanted to remove one particular node, it is enough if you change the address of its previous node. And there are various implementations of linked list which is there in practice. So what we are going to talk about is a single linked list, but there is one other implementation called as a doubly linked list which is available in Java. That is one other a complex data structure which is available. In singly linked list, imagine a structure like we have multiple nodes, and suppose imagine if you have 3 nodes which is available. The first node is called as the head node, which is going to hold the content and it's going to hold the address of the next node, and the next node will have its own content and it will have the address of the third node, and the third node will have only the content. Since there is no fourth element, the address of the third element will be empty. But when you take a doubly linked list implementation, there will be 3 parts in each and every node. So if you take the first node, it will have 2 address parts and it will have the 1 content part. Imagine if you have 3 elements in your doubly linked list. First element will be called as the head node. It will contain the content and it will have the address of the second node, and the second node will have its content. It will have address of the first node. At the same time, it will have the address of the third node, and when you take the third node, it holds the address of the second node and the content. Since there is no fourth element, it will not contain the fourth element's address. In case if you insert the fourth element, that will hold the address of the fourth node. Hope you found it you were able to imagine this particular concept. And there are much more implementations. You have a circular linked list and all those things. Let's not worry much about it. So basic thing is that each and every element in your linked list in memory is going to hold content as well as the address, which makes addition and removal of the elements much more easier, and it is also much more efficient. If your program involves lots of additions and removals of elements, then it is better to go for the linked list. And let's quickly try to see how to initialize your linked list in Java. So this is the sample program that we used for array list implementation. Let me remove it, and linked list, we are going to make use of linked list. So linked list, so my list equals new linked list. So this is how you have to create a linked list. So new linked list, and if you see, there will be an error thrown because we have not included the package. So linked list also resides in the Java util package as the array list, and linked list will implement the list interface. So this is how you have to create your list. As I told you before, like it's always better to write what type of elements your linked list is going to hold, and I'm going to make my linked list to hold the string. So I'm going to add these elements. So my linked list will hold the string elements. How can you add elements to your list? So my list dot add. So we have various methods that are available. So add method, using that method you can directly add the elements to your linked list, or you can even add it by making use of the index that is available. So index always begins with a 0. So you can add it by making use of, I'm going to add max, and at the same time I can also add it by making use of the index method also. So add of index, and if I wanted to insert it at the 0th element, then I can science. So this is how you have to add the elements to your linked list. How can you iterate the elements of the list? In our previous example, while talking about the array list, we iterated it by making use of the enhanced for loop. There we even told about the point that we can even iterate your list by making use of the iterator object. So iterator, you have to give the name of the iterator equals your linked list. Okay, your linked list dot iterator, and you have to include your iterator. So import iterator, it will also sit inside your Java util package. So this iterator can be iterated by making use of a while loop. So while iterator dot hash next, when there is an element which is available, then you can print it. So your iterator dot the next element. Now if you run this particular program, it gets printed as science and max. Why not max and science? Because even though we added max in the first place, I added science at the index 0. So science will be added to the index 0, and max will be pushed one element to the right, and max will sit in the first place. So index 0 will hold science and index 1 will hold max. Similarly, removing an element, you have your remove method implementation. So where you can remove the like your object directly, or you can supply a particular index and you can remove the element from your linked list. Hope you found this video informative. And one other important thing that we wanted to convey is that that's it. So hope you found this video informative. To reiterate what we have seen in this particular video, we have spoken about the linked list implementation of your list interface, and why are we using the linked list when there is already a list in place. So when comparing it with arrays in Java, your additions and removals are much more efficient by making use of the linked list, since it organizes the elements by making use of address of the pointers, where each and every element is a node and each element will hold the address of the next element. So if you wanted to remove or add a particular element, it is enough if you change the address. And additions and removals, the same method of the array list you can, and along with these methods for addition and removal, so there are lots of other methods, like you can remove the elements for making use of the remove method, and Also, there are like you can add it by making use of object or index. You can clear a list making use of the clear. And if you wanted to take a replica of your list, you can make use of the clone method. If you wanted to check whether your list contains a specific object or not, then you can make use of the contains method. And if you wanted to find whether your list is empty or not, you can make use of the isEmpty method. So this way we have lots of methods which are available in your list implementation. You can check it out in the Java docs that is provided by Java, or you can try to experiment it out with the various methods. Hope you found this video informative. If you have any questions related to the linked list implementation of the list interface, comment it out in the comment section. We will try to reply you out, or we'll try to make a video out of it. And if you found this video helpful, consider giving this video a thumbs up and subscribe to our channel for more exciting videos. We'll meet you in next video soon. Thank you.